Okay, so we're going to work out these problems, and then we're going to round to the right number of significant figures. So when you're doing these two numbers, or multiplying or dividing numbers that are in scientific notation, first you deal with the numbers in front, okay? So you have 8.25 divided by 2.11. Okay, when you divide that, what do you get? 3.909? All right, 3.909. Next, you divide the exponents. So they have the same base. They have a base of 10, so you can divide them. 10 to the 5th divided by 10 to the 2nd power gives you 10 to the 3rd. Okay, now you have to put these together. All right, so before we do that, let's look at the rules for significant figures. Okay, how many significant figures does 8.25 have? 3. Okay. Let me adjust this here. There. Okay, so this has 3 significant figures. And what about 2.11? 3 significant figures. Okay, so both of these numbers have 3 significant figures, so we have to round this to 3 significant figures. All right, so we're going to keep those first 3, but that number is possibly going to round up. If we look at the 9, does that 0 round up? Yes, it does. So let's round it to 3.91. And now I'll combine this and this into scientific notation. 3.91 times 10 to the 3rd power. Okay, and you're done with that. All right, so this is how you multiply or divide numbers in scientific notation. So let's try the next one. 2.55. You're going to do the first 2 numbers first. 2.55 times 1.1. Okay, when you multiply them, what do you get? 2.805. Okay. Now the exponents. 10 to the 5th power times 10 to the 2nd power. What does that give you? 10 to the 7th power. You have to add the exponents, right? 10 to the 7th power. Okay. Now, how many significant figures should this have? How many significant figures does 2.55 have? 3. 3 significant figures. 1.1, 2. So we're going to round our this number here to how many significant figures? 2. So underline the first 2. If you look at the number next to the 8, are we going to round the 8 up or leave it in 8? We're going to leave it in 8. So 2.8 times 10 to the 7th power. And you're done. That's it. 7 is just a slight bit more complicated. Let's try number 10. Okay, so let me erase this so we can see it better. All right, let's do the same thing now. Multiply the first 2 numbers. 5.67 times 9.2. What does that give us? 52.164. Okay. And then the exponents. We're multiplying. So 10 to the 4th times 10 to the 3rd. It's 10 to the 7th again. Okay. All right, so let's round this number to the right number of significant figures. What are we going to round to? 2 significant figures, because this has 2 significant figures. The other one has 3. Okay, so we round to the lowest number of significant figures, which is 2. So underline the first 2 numbers. Are we going to leave that 52 a 52? Yes, we are. So 52 times 10 to the 7th power. But we're not quite done yet. When we have a number in scientific notation, this number has to be between 1 and 10. Right now it's 52. So that means we have to move the decimal and make it a number between 1 and 10. So we're going to make it 5.2. Yeah, so now we made this 10 times smaller, so we have to make the power 10 times bigger. So that means this becomes 10 to what power? The 8th. Okay. There you go. So we move the decimal so that you can make that a number between 1 and 10. Yeah, because 52 is bigger than 10. All right, so that's how you work these out when they're in scientific notation. Deal with the first two numbers first, and then deal with the exponents, and then put it back together into scientific notation. Okay? All righty, we're done.